All right, so now we're going to add a routine to do the orientation. So I'm pasting this code. I've been using this code for quite a while, and it was originally from this link here, and I'll put that in the description too, to see where on the forums that was. This was 6 years ago. And let me go through the code. I'm going to go through this pretty quickly and not explain in detail. For one thing, I'm not really the math expert to explain the stuff that's going on, but I'll explain an overview of it. So first we pass this code, the grid orientation to use for aiming. In our case, that would be the cockpit down. And then the target vector. And this is the vector, not the location. The vector to aim the grid, where we want to aim at. And we will return true if we're aimed within the tolerances. And we use this to determine the mid-rad angle rad. And note this in radians, hence the rad, to see how close enough it is to stop trying to align. So what we're going to do here is we're going to go through each of the gyros. We're going to get its orientation matrix, and we're going to transform that from the direction that we want to go to what it's aimed at, so that we can figure out how to adjust the yaw, pitch, and roll on the gyro to match the yaw, pitch, and roll of the ship. So then we go through and we do the calculations, and I'll not go through this vector math. There are other places that go through it in detail. And then we check to see if we are close enough and then we don't override that gyro. And then we calculate how to control it. Then if we have to change something, then we are not aligned correctly. We normalize the values between the options, and then we multiply the rotation that we need to have with that control value to find out how much we need to change the yaw, pitch, and roll. And then there's an optimization here to see if the current value minus the pitch is greater than 0.01. And that's to check to see if we're changing it or if we're not changing it. Actually setting the pitch, even if it's the same value, is expensive. So we're only going to do that if we need. And then we do the same for pitch, yaw, and roll. And then we returned be aligned. And again, that's for all of the gyros we have in the list. All right, let's compile that code. And it's not going to do anything yet because we're not actually calling that code, but that will be next. Let me paste that in. And it's not doing anything yet, but it is there, and we can go and look at the code.